Hello, this is Xavier Bignale here at Microchip, Product Marketing Manager for the Secure Product Group, and today I'm going to talk to you about the TrustFLEX pre-configured secure elements and how do we use them to connect to Microsoft Azure IoT Hub. This is the webinar number 13 of the Shields Up series. So in terms of embedded security, I always start my sessions with those different layers that security is composed of. But today we're going to focus on a specific product of the Microchip portfolio, that is the secure element here. Microchip do offer a variety of microcontroller, processors, FPGA, and network controllers. So when it comes down to secure elements, one of the things you want to remember in terms of security practices is that the crypto algorithms, meaning the math, are triggered by a key, and the key is the secret. So the key triggers the algorithm, the secret triggers the math. So that's why you want to protect this key by any means possible, right? And that's where the value of secure element kicks in. Here are two theorems that are pretty interesting that says that basically everything in the system is public knowledge except the key, or should be public knowledge. That's Kirchhoff theorem, and Claude Shannon tells us that the enemy knows the system. So if you don't protect your keys, the keys is known, and this is why you want to protect them, because in the possession of the key, critical transaction can be impersonated. So you want to protect your keys in a secure element. It's basically a secure key storage that has a security prom 16 slot here in the case of the ATECC608. A hardware accelerators is CP256, SHA-256, AES-128, unique serial numbers, 2 monotonic counters, and a high quality random number generators. The secure element itself is equipped with active anti-tampering protection and side channel attack protections. In the microcontroller, because the secure element is a discrete solution, you'll find to be using the crypto-auth-lib library, which has the hardware abstraction layer, the HAL layers, that will allow the I2C command to be passed back and from the microcontroller to the secure element. So how do we place the keys there? So here's the challenge. The challenges. When it's time, it takes time to configure the secure authentication use cases in the device. So in so many cases, situations are already engineered, and engineers spend way too much time defining a simple authentication. So this is a place where engineers will need some help there to accelerate that time of development. And then there's a logistic complexity of securely provisioning keys and credentials. So what does it mean really? It's very difficult to ship keys globally for any project size, meaning a project could be 3,000 units, could be 10,000, could be 10 million units for the year. How do you ship key globally for any project size? Then you want to keep the key isolated from everything, from the development through the production, your manufacturing site, your contract manufacturing, distributors, and even the end user itself. So how do you isolate keys when you need to ship them globally? And you have to do all of that in a fragmented marketplace, right? So here are your challenges. So Microchip launched the Trust Platform for the crypto authentication family. It's a scalable and adapted provisioning service composed of a 3-tier offering: the Trust Go, TrustFLEX, and Trust Custom. We've talked about it in an earlier session of the Shields Up number 2 webinar. So please refer to Shields Up number 2 to have more complete details on the entire platform. So Trust Go is basically a pre-configured and pre-provisioned secure element. It's a black box that's locked. That comes with MOQ, a minimum orderable quantity of 10 units. And that's what will offer you the shortest development time, because you don't touch the secure element. It comes with the private key, the certs, and something we call the manifest, which I'll explain later on. The second offering is the one we'll be using today. It's the TrustFLEX, which is a pre-configured and yes, pre-provisioned, but we left the slot unlocked for you to use your own certificates and your own credentials and override the default ones that we're proposing already in the device. The MOQ, including provisioning here, is 2,000 units. And the third offering is the Trust Custom, which is a fully customizable secure element with an MOQ of 4,000 units, including provisioning. So what we're going to talk about today is the TrustFLEX ATECC608 and how to implement secure authentication with Microsoft Azure IoT Hub. So let's dive into the TrustFLEX configuration set. As I said, it was pre-configured with policies. And as you can see, what you have here, the slots we're going to be using are slot 0, 10, 11, 12. So basically it's your private key that when you're in production, those things are locked, right? So you'll have your private key in slot 0, and you're going to have the device search, the signer search, and the signer search signature between 10, 11, and 12. So TrustFLEX, beyond the certificate authentication, you can do JSON Web Authentication, JSON Web Token Authentication, Secure Boot Assistant, so you verify the digest or the signature of a code image. You can verify an OTA, an over-the-air update. So again, you're going to verify the signature. You can do IP protection, so verify the signed code is genuine during runtime of the system. You could do small message encryption across the SQRC bus if this is what you want to do. You can do key rotation, as you can see with those slots. You can use the IO protection key that pairs the micro to the secure element and so forth. So that's what our TrustFLEX does. It offers multiple predefined use cases, and I think there's more of them. If you go to our webpage, you will see all the use cases, and we'll show you that in a minute. So from there, the only thing I'm going to concentrate on is certificate authentication for Microsoft Azure IoT Hub. So when you implement TrustFLEX with third-party PKI on Azure, this is how it looks like. So you're the customer, and certificate issued by the customers at their side. All customers have an IT team that handle this process. So basically, your IT team is capable of and very knowledgeable about spinning certificates chain. This certificate here could be a root, could be an existing certificate chain that exists in the company, could be bought from a third party, could be made by the customer. We don't necessarily recommend that. You really want that root to be protected. So from there, the customer creates a certificate for Microchip production signers. Once that's done, there's something called the secret exchange that kicks in with Microchip to allow the certificate generation on the customer behalf. The rest of the process happens into the Microchip Secure factories. So there is an agreement between Microchip and the customer. So basically, Microchip will send a certificate signing request, which the customer will sign with the customer certificate and allow Microchip to generate specific production signers in the behalf of the customer. Those signers will be loaded in the Azure environment by the customer. And then the next step, Microchip device certificate are loaded into the ATECC608 TrustFLEX inside Microchip Secure Factory and signed to generate the private key. And a standard part number is created then for all customers using their certificate chain. Obviously, your certificate, your part number. And that's what we're going to construct in a minute. And of course, all the handling and manipulation of certificates happens within Microchip Secure Factories. Now, how do we turn months of development to minutes? That's where the Trust Platform Design Suite kicks in. What it is, it's software that offers you a tool to select the pre-configured use case that you want. It basically runs something called Jupyter Notebook. It's a bunch of Python executable tutorials that helps to implement each use cases. And then we offer you C-code project for each of the use cases. That works on any IDE. Here we'll use MPLabX. And finally, we have a little utility that will help you to trigger the secret exchange. All of the Trust Platform can be available here on microchipdevelopershub.com. So let's get into the hands-on and show you how we turn month into minutes. We'll do a live demo here. So for prototyping, we'll use the Trust Platform Design Suite software. We'll generate a manifest uploaded to the Microsoft Azure IoT Hub using the Trust Platform. I have already updated the Wing 1500, which is the Wi-Fi that we are about to use. And we're going to flash the code example into the SAM D21, the Cortex M0, and we'll connect to Azure IoT Hub. For production, you will want to start the whole process. You start the secret exchange process by using the ATECC608 TFLX-Proto from our e-commerce stores. Once you have those Proto, which is short prototype devices, you will confirm the provisioning is successful as you complete the secret exchange process, and Microchip will provide you with manifest files into your e-commerce account that you can leverage, and that's where you get your signer certificates. And then you go to the production with your custom part number starting with ATECC608, and then you will have a few digits associated to you. Okay, so from a kit standpoint, we are using the DM320118, which is an ARM Cortex M0. It has already the ATECC608 Trust and Go, TrustFLEX, and Trust Custom soldered down here to give you choice for the platform that you desire to use. And we have an internal debugger that's right here at the top of things. So that's what you'll buy. I think the board cost about $13, if I'm not mistaken. And then you have to procure yourself the Wing 1500 from microid.com that has a microbus pinout and has the TLS and TCP IP stacks integrated within the modules. And that's your Wi-Fi BGN module here. So what's happening when the connection tries to be established? Microsoft Azure server certificates support RSA and not ECC when you try to reach out to the embedded devices. So you got to know that. So the RSA is handled by the Wing 1500, and then when the device reaches out to the Microsoft Azure server, the server accepts the client Cipher suite both at RSA and ECC, and obviously we'll be using the ECC curve as we present the signature to Microsoft Azure. So in other words, what's happening here is we'll have a signer certificate inside the ATECC608, and we'll basically push the signature and the signer public key into the host, which is the cloud. That'll verify it with the associated public key. We'll present a device certificate signature and device public keys again to the host that will use the signer public key to run an ECDSA verify along with the signature of the device and the device public key. And finally, the last step, we'll send the cloud will send a random challenge that will be signed by the 608, and that random challenge will also be sent to the cloud that will perform an ECDSA verify. Once the check is working, we authenticate the connection. First thing we're doing, go to microchip.com/TrustFLEX Azure. In this page, we'll see a bunch of details, all the use cases that TrustFLEX offers beyond secure authentication, all the tools to use. You're going to have multiple trainings and development tools and all that stuff. The one thing I'm going to want your attention on is that Trust Platform Design Switch, which you'll click on, and it'll point you to this wiki page. It's a user manual on how to install the software itself. Follow the procedure. At some point, you'll download the installer. Once you're done completing all of that, what is going to happen on your laptop, you'll have something called Anaconda. So when I search for Anaconda, I'm going to look for the Anaconda Navigator Trust Platform. Once I launch it, the interface I have here is this one. I'm going to click on Jupyter Notebook. And basically, this is where I'm going to find all my Python executable. And what happens when I click there, it's going to launch something like this, which is basically an image of a representation of my desktop here. And I've installed it there in Trust Platform Design Suite is my folder architecture. I'll point your direction to the asset folder. This is where you have the FactoryX program, first firmware you want to flash the microcontroller with, and this is what we're going to do immediately. I'm going to go to MP Lab and go to Open Project. And where I'm at here, I'm under username, Trust Platform, Design Tool, Asset, and this is where I'm at here. So I've already done that, and my project is already open. The only thing I'm going to do is plug my board, which is plugged in, and build the whole thing. I'm going to click OK here, and boom, it loads the program. So once I have my FactoryX program here, I want to also show you, actually in the assets, you also want to run the Wing 1500 firmware. So what you'll do, go to your folder architecture, run the batch file. I've already done that, so I'm not going to do again, but make sure your Wing is updated. Back to the design tool folder, In the docs is where all the PDFs are for pretty much every use cases. Something that's going to be interesting for us is the Azure IoT Hub detail CVS. So let's take care of that too. What I want to do is log into my portal.azure.com. It's my account here. And let me go back to the overview. When I click on the overview, those are the important information, my subscription ID and my host name. Those are the important information because I'm going to have to copy what's before the dot here. I'm going to have to copy that and go to wherever my folder is. So if I go back under user, me as a user, and Trust Platform, Design Suite, Design Tools, Docs, and I'm going to open my Excel file for Azure. This is where I want to have my IoT Hub. So as you can see, it's already there. And then I also want my subscription ID, which I'm copying here. All right, now I'm set. I'm going to save and close. And my setup start to be quite ready. All right, let's go back to the design tool folder, to the TrustFLEX. Next thing is to run the resource generation and open the Jupyter notebook for the resource generations. And what's going to happen there is I'm going to go to kernel, restart and run all, and now my Python executable code is running. And what it's creating a chain of certificate for the sake of prototyping. Again, I'm repeating, for the sake of prototyping, don't use that in production, to help you getting started in minutes. So we're gonna have root certs, signer certs, device certs, and the scripts that are provisioning the device through the kits are also inside this executable. When you see that little black dot there, that means the executable is still running. It's going to take a few minutes because there's a lot of modules there are a lot of modules to install, and you can see that here. So now I'm going to click on custom cert and enter my org name. It's creating certs, root, everything I need. It's creating the manifest, and I'm done. What I've done here, I've provisioned with my prototype chain of certs, the ATECC608 TrustFLEX, and I'm done with the secure element. So like we said earlier on, that's how we turn months of development in 2 minutes. We don't stop right here at Microchip. We actually give you more than just that. So now if I go back to my TrustFLEX folder, and so I have provisioned my secure element, I'm good. I'm going to do the implementation with Azure. I'm going to go to the notebook, launch the notebook, and then I'm going to execute the notebook similarly, clear the output, and then run the notebook here. So what's happening, the notebook is executing here. As you can see the red dot, and we're going to help you to onboard with Azure. First, we're going to help you to log in. So now we have your laptop getting ready to talk to your cloud account. So here's my account, and I've logged in successfully. So what happened to my button here? Turned green. So I'm good. Next step, register the signer that we've just created with the resource generation. So I clicked on it, and technically the button should turn green as the registration into IoT Hub is successful. It's going to take a few minutes here. And the button turns green, which means my registration of the signer has been successful into IoT Hub. Next, I'm going to register the device per se and click on the button. And now all that registration process is done right from the tool for the prototyping phase. Same thing here, I'll take a few minutes and then we're done. The next step is for me to go back to MP Lab and open the Azure product, which is located under Design Tool, TrustFLEX, Custom PKI, Azure, C, MP Lab, right? And I'm going to open this project here. MP Lab is now opening the project. And if we looked at how the project is open, where I want to go to is actually to go to source files here and open Cloud Wi-Fi task. And the reason is within the Cloud Wi-Fi task, what I want to change is the main SSID. I'm not going to obviously disclose mine here. the password of my hotspot, and the cloud endpoint. The cloud endpoint is basically this here. That's just before the dot here on Azure. Okay. Once I have that, I'm going to basically build a project and we'll test the platform. To test the platform, I'm going back to my overview here and scroll down on the left and look for something called IoT devices. In the IoT device, I'm going to see that my new device was recorded this afternoon. I believe it's this one. Let's take a look and send it a message. So when I click on send a message and enter this command here and send the message here, it's going to send a message successfully to my board and my LED is going to go on. If I change that to off, send the message again, my LED is turning off and it's going to take a few minutes. There you go, here we are. We've demonstrated the whole solution is working. So to find that part here, you go to microchipdirect.com and look for the TrustFLEX, TLS, and the package you want, and Proto. I'm going to choose the UDFN. Here's my Proto part. This is my starting point. You're going to order that part, and at the same time, what you're going to do here, you're going to initiate the secret exchange here. I'm back to my TrustFLEX Azure page. And when I click on initiate the secret exchange, it's basically going to take me to the Salesforce interface. You create your account and there's a pretty cool user manual that explains the entire procedure when you go to design tool, docs, and at the end you have something called TrustFLEX guide, secret exchange process. Click on this PDF and everything is explained there. Let's take a look immediately. And you can see the entire procedure on how to set up TrustFLEX, the Salesforce account, how to request what is still in Salesforce, everything, absolutely everything, how to use the utility, everything is there. When it comes down to production, how do we went through the provisioning, went through the onboarding with the kit for prototyping. Now we're going to talk about the production ordering flow. If I'm the customer, the only thing they have to do is use the TrustFLEX use case tool. That's the Trust Platform Design tool. Use the TrustFLEX notebook and the Microsoft Azure example. File and encrypt the secret package. So that's where you'll fill all the information that you want to the device to contain, and that will be passed down to Microchip via, again, our secret exchange process. The encrypted file is given to microchip.com/support. That's a Salesforce ticket, and Microchip will create provision secure elements. Any customers or distributors order validation article and production parts can be placed there. Microchip provisions and ships the TrustFLEX devices to the customer, so the customer indicates simply the address. It's a drop shipment at the desired location at the given CM, and that's where the magic starts to happen, because if you, the customer, decide to change your CM for various contractual reasons, the only thing you have to do with your pre-provisioned keys into Microchip Secure Element is change the address. You don't have to worry about the CMs having your keys and being some type of hostage situation. That's offloaded. And furthermore, you reduce the cost of the customization of your system, because each key needs to be unique to each system, which creates customization into your test environment. Microchip take that burden away from your product supply chain, and we ship those pre-provisioned devices wherever you desire. And finally, the public credentials are uploaded to any cloud platform. So here will be Microsoft. And we've finally completed secure, trusted, managed authentication using, you can use any PKI providers really. And it's a configuration, TrustFLEX is a configuration that can fit most of the authentication use cases. So as you go to production, Microsoft also helps you with something called a device provisioning service. It basically help the bulk uploading of public keys in the Microsoft Azure environment. So you will register first the device public keys to DPS, and DPS will authenticate with the targeted Azure IT Hub. That helps with load balancing across the globe. Azure IoT will provision the register statuses of the embedded device with the desired state. So meaning if you have, your board is supposed to start with LED on. So that's what DPS will push into the device at the time of connection. That's their definition of provisioning. You can watch all the details of this discussion we had with Quinn Tran from Microsoft Azure at the following URL on YouTube. So the challenges, if you remember, it's the time it takes to configure secure authentication, configure the device itself with the selected the right use cases. So we've done that for you. That's the pre-configured TrustFLEX. And remember the complex logistic aspect of the supply chain on how to handle keys into your device, meaning shipping keys globally for any project size, keeping keys isolated from pretty much everything, and all of that to happen in a fragmented marketplace. So again, the Trust Platform Design Suite software turns those months of development into minutes. And especially if you pick up a Trust & Go that's pre-provisioned, a TrustFLEX that's pre-configured. In terms of logistic, the way the Microchip Trust Platform helps, we do ship globally under EAR 99 export rules. There are 5 countries that we can ship with. And that's not just related to the secure element itself. It's anything that has any semiconductor that has any type of crypto inside, whether it's a microcontroller, connectivity, or crypto devices. All of them apply to the same rule. There's nothing new there or unusual. There is no more high volume MOQ limitation like there used to be in the past. And we've heard the market is still struggling with averages around 100,000 units as MOQ with provisioned devices. We don't. Simple. We provide an ideal service for today's fragmented marketplace. The marketplace in IoT is vast and very spread out in terms of project profile and customer profile. We offer that very nicely now. And finally, it gives everyone access to secure authentication and an easy way to consume. Finally, subscribe. We have a page. If you go there to microchip.com/club, click on subscribes, and you'll stay up to speed with the upcoming webinars. We have quite a few coming up still for this year and going into much later than that. If you have questions, we'll take the questions. Feel free to contact your local sales representative. And for all the information we talked about, everything is available at microchip.com/TrustFLEX Azure. Thank you very much for your attention, and we'll see you in the next webinar.